Magnetic materials. Here are priming questions. Before we can talk about what really causes magnetism, we need to think back to chemistry now. And so what you remember about chemistry and matter is that everything's made out of protons, neutrons, and electrons. These electrons we've been focusing on a lot this particular term, and now we're going to talk about it as it relates to these magnetic fields. And so if you look at this, this is called the off-bow diagram, and it shows you the electrons represented by the arrows, and hopefully you remember this, the electrons spin, and that spin is shown by the direction of that arrow. So you can see the spin here. Here it'll be a counterclockwise and here a clockwise. And with the way that the electrons are filled in, they're filled in half at a time, all with the same spin. Now, depending on the combination of these electrons will determine the magnetic properties of that material, especially if it's in an alloy where they combine together. And so you can see the off-bow diagram here, and this only goes up to the p orbital. If this were to keep going, we would also have d and f. And here's a simplified version of the orbital shells. If you remember from the quantum mechanics, it'll show you the dumbbells or the sphere, things like that. But this is a simplified version of this. And you can see that these have unpaired electrons, and these unpaired electrons are going to be very important for us because when they are unpaired, they have the same spin, and because they are spinning in the same direction, their magnetic fields are matching. Whereas you can see here, the magnetic field lines of the two electrons that have opposite spins, they have opposite magnetic fields that you can think of as canceling each other out. So there are three different types of magnetism that you want to be familiar with. We have diamagnetism, we have paramagnetism, and we have ferromagnetism. Every material exhibits diamagnetism to some extent, and this is caused by paired electrons. So again, this occurs in all materials. And what's interesting about diamagnetism is its tendency to oppose a magnetic field. There are some special materials which I will show you in class that can actually levitate inside of a magnetic field, and depending on what are the environments for these materials can dictate how well it works. And I'll show you some pictures of that in just a moment. Paramagnetism, on the other hand, this is caused by unpaired electrons, and this can overpower the diamagnetic properties of the material, which allows the electrons to align itself to the magnetic field. The catch here is this only lasts as long as the field is there. You take away the field, it is no longer magnetic per se. Ferromagnetism, on the other hand, not only can these unpaired electrons align to the magnetic field, but they can also align to each other. And that's what's critical for ferromagnetism, which means that these electrons can stay aligned, making what we call permanent magnets. All right, so diamagnetism. If you have some special materials, and I'll show you this in class, and some powerful magnets, you can actually levitate that material on top of the magnets, or you can also see it over here. Scientists have actually done this with a frog as well. So remember, all materials are diamagnetic, and the frog was actually able to levitate. And here, you can also use a superconductor with a magnet, and it will produce the diamagnetic properties as well to show you that to you. Now for paramagnetic, I have a quick video that I found.
Frostbite Theater presents Cold Cuts, no baloney.
Just science.
Hi, I'm Joanna.
And I'm Steve.
And this is a test tube of liquid nitrogen.
And this is a test tube of liquid oxygen.
Let's see what happens when we pour the liquids past the poles of a strong magnet.
Okay.
Now, liquid nitrogen isn't normally magnetic, but each of the nitrogen molecules acts like a tiny magnet when it's exposed to a magnetic field. This effect is known as diamagnetism. That's just a fancy way of saying that each of the nitrogen molecules is repelled by the magnet's magnetic field. So, when I pour the liquid nitrogen past the magnet's poles, it doesn't look like anything special happens. The nitrogen just falls past the magnet. That's because the diamagnetic effect is very weak, so we don't normally observe it. All materials are at least slightly diamagnetic, but because the effect is so tiny, we don't normally notice it.
Just like nitrogen, oxygen isn't normally magnetic. And just like nitrogen, each molecule of oxygen behaves like a tiny magnet when it's exposed to a magnet's magnetic field. Oxygen behaves differently than nitrogen, though. The way oxygen behaves is called paramagnetism. That's a fancy way of saying that each molecule of oxygen is attracted to a magnet's magnetic field. So, when I pour the liquid oxygen between the poles of the magnet, it sticks. And we can even make a little bridge out of liquid oxygen that'll stay there until the oxygen finally boils away.
Alright, so that'll be good enough for the video, and just so you know where I got it from, this is where the video is from. Alright, so that is paramagnetism. We're going to spend a lot more time on ferromagnetism later on, but as a quick application, for many of you, you've probably been to the doctor with a broken bone or something hurting, and you've had an MRI scan. The MRI scan is actually an application of these ideas. And so MRI actually stands for magnetic resonance imaging. And so what happens is there's a strong magnetic field. This is why you can't wear your watches or your credit cards or anything like that. It'll erase your credit cards. You have a strong magnetic field, and it will actually align the electrons in your body in that specific area, and then it releases the magnetic field, and then when your electrons go back to how they were, it releases a signal that the machine then records, and it can scan, essentially, a layer of your body at a time. So this is essentially a two-dimensional slice. And this is just one application of this idea and these concepts.